Imagine a world where mountains don't grow. They explode from the ground overnight, where the surface rises and falls by 100 meters every single day, where volcanoes erupt with such force that they blast material hundreds of kilometers into space. This isn't science fiction. This is real. And it's happening right now on a moon that's closer to Jupiter than our moon is to Earth. What you're looking at is one of the most disturbing images ever captured by NASA. These bizarre alien structures, seemingly created by forces we've never seen anywhere else in our solar system. This is Io, Jupiter's innermost moon. And scientists have only just begun to understand the hidden chaos that's tearing this world apart. By the end of this video, you'll discover why this small moon defies everything we know about planetary science, and why we might never see images like this again. Today, we're going deep into one of the most extreme environments in our solar system. We'll uncover how a moon smaller than Earth's can generate more volcanic power than our entire planet. The discovery that changed everything we thought we knew about moon. Why mountains on Io literally burst from the ground like something out of a horror movie. And the tragic reason why. Humanity might be abandoning this incredible world. But first, we need to understand where Io fits into the massive Jupiter system. Because without Jupiter, none of this chaos would exist. Jupiter isn't just a planet, it's practically a miniature solar system of its own, with nearly 100 officially recognized moons orbiting the gas giant. And that number keeps growing as we discover new objects. Most of these moons are tiny, insignificant rocks, but 4 of them are massive. We call them the Galilean moons because they were first observed by the Italian astronomer Galileo Galilei in 1610, using one of the very first telescopes ever constructed. Think about that for a moment. Over 400 years ago, with primitive glass lenses, Galileo saw these 4 worlds and changed our understanding of the universe forever. Let me introduce you to the family, Callisto, the outermost moon, a frozen, dead world covered in ancient impact craters. Nothing moves here. Nothing changes. Ganymede, the largest moon in our entire solar system, even bigger than the planet Mercury, also made of ice and rock, also dead. Europa, now this one is interesting. Beneath its smooth ice shell lies a vast ocean of liquid water. It's one of the most promising places to find alien life in our solar system. Scientists believe there could be more water on Europa than in all of Earth's oceans combined. And then there's Io. Io orbits just 350,000 kilometers above Jupiter's clouds. For perspective, that's about the same distance as Earth to our moon. In cosmic terms, Io is practically kissing Jupiter. In terms of size, Io is roughly the same as our moon, just slightly bigger and heavier. But here's where things get weird. Io is the most dense moon in our entire solar system. Why? Because unlike its icy siblings, Io is made almost entirely of rock and metal. Out here, billions of kilometers from the sun, where everything should be frozen solid, Io somehow lost all its water. Scientists believe it has the lowest water content of any known body in the solar system, even drier than Mercury, the planet closest to the sun. How did that happen? We're still not entirely sure. But it gets stranger. On March 5, 1979, NASA's Voyager 1 spacecraft made its historic flyby of Jupiter. The probe was racing through the system at incredible speed, snapping pictures as fast as its primitive cameras could manage. When the images came back to Earth, scientists couldn't believe what they were seeing. From a distance of 20,000 kilometers, even with low-resolution 1970s camera technology, Voyager captured something shocking: 9 distinct volcanic eruptions blasting from Io's surface simultaneously. This was the first time in human history we discovered active volcanoes on another world. And not just 1 or 2 volcanoes. Io has approximately 400 active volcanoes dotting its entire surface, making it the most volcanically active place in our entire solar system. More active than Earth, more active than Venus, more active than anything. Now here's the paradox that confused scientists for years. Outside of the volcanic zones, Io's surface temperature plummets to minus 130 degrees Celsius. That's colder than the coldest place on Earth by a massive margin. The sun is simply too far away to provide any meaningful warmth to the Jupiter system. So where is all this volcanic heat coming from? The answer lies in Io's treacherous location. And to understand it, imagine being caught in a cosmic tug-of-war. On one side, you have Jupiter, a planet so massive that its gravity is 318 times stronger than Earth's. Io is close enough to Jupiter that it's constantly being pulled with enormous force. But it's just far enough away to avoid being completely torn apart or swallowed whole. On the other side, you have the 3 other Galilean moons, Europa, Ganymede, and Callisto. Their combined gravity isn't nearly as strong as Jupiter's, but it's enough to pull Io in the opposite direction. This gravitational interference disrupts Io's orbit. Instead of moving in a perfect circle around Jupiter, Io travels in an oval-shaped elliptical orbit. This means sometimes Io is really close to Jupiter, and other times it's further away. And this cycle repeats approximately every 42 hours. That's less than 2 days. So Io never gets an even, stable exposure to Jupiter's gravity. It's constantly being stretched and squeezed and pulled and released as it orbits. You know how the moon causes tides on Earth? Our oceans rise and fall by about half a meter on average due to the moon's gravity pulling on the water. Now imagine that same effect, but amplified to an insane degree. When Io is at its closest point to Jupiter, the planet's gravity lifts the moon's surface by as much as 100 meters. That's not water rising and falling. That's solid rock being stretched like rubber, giving Io a slight egg shape. All of this constant stretching and squeezing acts like a massive cosmic pump, driving energy deep into Io's interior. And that energy has to go somewhere. It erupts as volcanoes. When you think of a volcano, you probably picture a cone-shaped mountain with lava and ash shooting from the top, like Mount Vesuvius or Mount Fuji. Those volcanoes form on Earth because of plate tectonics, where sections of our crust collide and force rock upward. Io doesn't have plate tectonics. Instead, lava erupts from cracks that form as the moon's surface stretches and tears under Jupiter's relentless gravitational pull. When a volcano on Io erupts, it's violent beyond imagination. The initial blast can throw lava dozens of kilometers straight up into space. And above that, a massive plume of sulfur gas can rise for hundreds of kilometers that's higher than the International Space Station orbits above Earth. Sulfur is always present in volcanic activity on Earth, too. If you've ever seen volcanic rock with round holes all over it, those holes were created by trapped pockets of sulfur gas escaping. All of this volcanic activity creates a thin but dynamic sulfur atmosphere around Io. Depending on how many volcanoes are actively erupting at any given time, the atmosphere can range from about 1/3 the density of Earth's atmosphere to nearly double. Most of the sulfur that gets blasted into space eventually falls back down and settles on Io's surface. And this is what creates those bizarre, vibrant colors we see from orbit. Io looks like an artist's palette, a world painted by fire and ice. Unlike Earth, volcanic activity on Io doesn't build up mountains or shield structures. Instead, after the violent eruption, the surface tends to collapse downward, and molten rock fills the void to create massive lava lakes. The biggest one is called Loki Patera, named after the Norse god of mischief. It's 200 kilometers in diameter. To put that in perspective, that's about the distance from London to Paris. In the center of this enormous lava lake sits a giant island of solidified rock, surrounded by a churning sea of molten material that constantly rises and falls. You might assume that Io has a structure similar to Earth, a solid crust floating on top of a planet-wide ocean of magma. But we're pretty sure that's not the case. Space probes sent to the Jupiter system have measured Io's gravity field as they fly past. And what they discovered is that the gravity pull is very uneven across the moon's surface. This tells us that magma isn't evenly distributed throughout Io's interior. Instead, it's probably trapped in localized pockets of molten rock that form in the specific areas, experiencing the most intense tidal flexing from Jupiter's gravity. So what you end up with are hundreds of separate volcanic engines hidden underground, each one operating independently. This means every volcano on Io behaves a little differently. Some are explosive, some create lava lakes, some are constantly active, others are dormant for years. It's like Io has hundreds of beating hearts scattered across its interior, each pumping molten rock to the surface. Now here's where things get really strange. If volcanoes and plate tectonics aren't creating mountains on Io, then where did this thing come from? This is called Steeple Mountain. Standing somewhere between 5 and 7 kilometers tall, it looks like a church spire. Or the Eye of Sauron from Lord of the Rings. We can see such detailed images thanks to NASA's Juno spacecraft, which arrived at Jupiter in July 2016 on a 5-year mission to study the gas giant's atmosphere. After completing that primary mission, Juno was repurposed to investigate the Galilean moons. Juno completed 2 incredibly close flybys of Io. The first on December 30th, 2023. The second on February 3rd, 2024. Both times the spacecraft came within just 1,500 kilometers of Io's surface, closer than any probe had been in decades. What Juno revealed is possibly the most unique landscape in our solar system. Steeple Mountain isn't alone. The moon is covered in tall, spiky mountains jutting straight up from the surface. The tallest rises 18 kilometers. That's about double the height of Mount Everest. But here's what's really strange. Unlike mountain ranges on Earth, these structures are all lone wolves. There are no dense groupings or chains, just seemingly random peaks stabbing straight up into space. That tells us these mountains didn't form slowly over millions of years. They burst from the ground suddenly, like something out of a horror movie. We think this is still linked to volcanic activity, just in a very unusual way. Remember how we said Eo's volcanic eruptions cause the surface to collapse and form lava lakes? Well, scientists believe that downward pressure actually causes nearby rock to get pushed upward to compensate. Imagine if every time a sinkhole opened on Earth, a new mountain just sprang up right beside it. That's what's happening on Io. It's a bizarre natural process that's been playing out for billions of years, with the surface in a constant state of rise and fall, thanks to Jupiter's relentless gravitational torture. These incredible images could be the last close-up views of Io we see for decades, or maybe forever. NASA's Juno spacecraft is slowly running out of fuel, and when it does, it will be deliberately crashed into Jupiter to avoid contaminating any of the potentially life-bearing moons. There are 2 new robotic explorers heading to the Jupiter system, but neither of them will visit Io. Juno Moon's Explorer was launched by the European Space Agency in April 2023. When it arrives at Jupiter in 2031, it will study Ganymede, Callisto, and Europa, focusing specifically on their icy surfaces and hidden oceans. Europa Clipper was launched by NASA in October 2024 and will arrive in 2030. As the name suggests, this mission is directed specifically at Europa, searching for signs of alien life in the water beneath its ice shell. That leaves Io as the odd one out. There's no probe heading there any time in the near future. And that's not because Io isn't deeply fascinating. It's largely because we didn't realize just how incredible the moon was until we saw those stunning Juno images just a couple of years ago. Also, let's be honest, Io definitely doesn't have aliens hiding in underground oceans, which automatically drops its priority level in the eyes of mission planners and funding committees. But priorities are changing at NASA. There's exciting new leadership emerging. Unprecedented rocket technologies like SpaceX's Starship are becoming reality. Private space companies are entering the game. Sometime in the not-so-distant future, we could be studying the deep solar system just as thoroughly as we investigate Mars and our own moon. Until that day comes, we have these images, these glimpses of a world unlike any other. A moon caught in an eternal battle between the crushing force of gravity and the explosive power of its own volcanic fury. Io reminds us that our solar system is far stranger and more violent than we ever imagined. And somewhere out there, right now, hundreds of volcanoes are erupting on that small moon. Mountains are bursting from the ground, and the surface rises and falls by 100 meters with every orbit. All because of the invisible hand of gravity reaching across 350,000 kilometers of space and slowly tearing a world apart. Until then, we'll always have Steeple Mountain. If you found this journey through the solar system's most violent world fascinating, hit that like button and subscribe for more deep dives into space mysteries. What other extreme worlds should we explore next? Let me know in the comments below.